Question 16 from the 2025 National Physics Exam from the SQA. A kettle, a television and a microwave are connected to the main supply. The kettle has a power rating of 2.6 kilowatts, the television has a power rating of 170 watts and the microwave has a power rating of 900 watts. Which row in the table shows the appropriate fuse ratings for the kettle, the television and the microwave? Well, the rule of thumb is as following. The power rating greater than 700 watts will require a 13 amp fuse. So we look at our list here, we can see that for the kettle it's going to have 2.6 kilowatts, so that's going to need a 13 amp fuse. The television, well, there's only one fuse there, that just needs a 3 amp fuse because the power rating is 170 watts. But the microwave is above 700 watts, so that deserves a 13 amp fuse as well. So which one has got 13, 3 and 13? It's going to be response B. Question 17. A group of students sets up the experiment shown to determine a value for a specific heat capacity of water. And there's the setup there. It says the students make the following statements about how the experimental procedure could be improved. Now we look very closely at the first statement is insulate the beaker to reduce the heat loss to the surroundings. Well, that's true, because if we don't insulate the beaker, heat will be lost to the surroundings, therefore we have to put more heat in to raise a given temperature. So to improve the experiment we have to add insulation to the beaker, so we'd have to add some sort of foam insulation. So statement 1 is correct. We want to move the immersion heater further into the water. If you look very closely, as you can see that quite a bit of the immersion heater is outside the water, which means it's not completely heating up the water, it's heating up the air. So to improve that experiment, you have to have the immersion heater right underneath the water. So statement 2 would be correct as well. Statement 3, use a stopwatch to measure the time for which the water is heated. Well, really we don't need that because the joule meter is going to give us the reading here of the power supplied in of the amount of energy supplied into the water through the heater. So we don't really need to have a timing event here. We can just go right away and read the joule meter to get the energy which is put into the water. So we don't really need that one there. So according to this then we have got statements 1 and 2 are true, and that means our response C is going to be the proper one. Question 18. A hot substance is cooled. The graph shows how the temperature of the substance changes with time. So it's a temperature time graph. I'm being asked to judge whether the following 3 statements are correct, or if 1 or 2 are correct or 3 is correct. So before we do that we have to take a look at the graph and understand what is happening at the graph. And our key point here to remember is that the plateaus of the graph, this is this point here and these points here, the temperature is not rising, so these are the changes of phase. These are when the substance is changing from one phase into another. So if we go the opposite way and start here and say that part in there is solid, and this part in here is a change of phase when the solid goes into a liquid, and then we have this part up here is all liquid being heated up, and then it gets this part here, we have to have the liquid going into a gas. And of course after this point here we're going to have just simply the gas in that part there. So what we've got a gas cooling down from 160, it changes into a liquid at this point, then the liquid cools down and it changes into solid, and the solid cools down. So we now know what's happening with the graph. So let's look at each statement in turn. Statement 1, the boiling point of a substance is 120 degrees Celsius. Well, the boiling point is when the liquid starts to change into a gas. So that is there, all the liquid is here, it's changing into a gas, and that temperature is going to be 120, where it's changing state, it's changing into a boiling point. This is the actual boiling point of the liquid. So that statement is correct. Statement 2, at a time of 40 minutes, the substance is a gas. Well, we look at 40 minutes here and go up here. We're at the start of this point here. Now, that point here is just the beginning where the liquid is beginning to change into a gas. From here to here, you're going to have a mixture of liquid and gas until you get to this point here where it's all gas. So to say that at a time of 40 minutes we have all gas is the wrong statement. You're beginning to change from the liquid into the gas. Statement 3, the melting point of the substance is 20 degrees Celsius. The melting point is when the solid begins to change into a liquid, and that's that point there, solid changing into liquid beginning here, and that's at 20 degrees, so that is correct. So according to our data, we have got statement 1 and statement 3 correct, and that's going to give us a response of C. Question 19. A ballet dancer wears shoes that have a flat section on the front called a platform. When the ballet dancer stands on the tips of her toes, the platform on each shoe is flat on the surface. Now the area of the platform on each shoe is 1.6 times 10 to minus 3 metres squared, and the weight of the ballet dancer is 520 newtons. And we're asked to find out the pressure exerted on the floor by the ballet dancer. Well, we know from the relationship sheet that the pressure exerted on the floor is the force divided by the total area. And we know that the force for the ballet dancer is going to be 520 newtons. That's going to be the weight of the ballet dancer, 520 newtons. But we have to take into account that she's standing on two platforms. There's the two areas there she's going to be standing on. And we know that one of the areas is 1.6 times 10 to minus 3. So really the total area for that would be 2 times 1.6 times 10 to the minus 3 metres squared, because we're standing on two areas. So in our calculation we have to put down the area as 2 times, and it's going to be 1.6 times 10 to the power minus 3, and we're going to have metre squared for that one there. Okay, so therefore if we do that in a calculator, we get an answer of 1.62500, and remember it's going to be Newton metre squared, or going to be pascals, because Newton metre squared is the same as a pascal. To put it into two significant figures, we're going to have a standard form here, 1.6 times 10 to the power 5, and we can change the Newton metre squared into the unit for pressure as the pascal. So our response is going to be, in this case, 1.6 times 10 to the power 5 pascals. It's going to be response D. Question 20. A tennis ball contains a fixed mass of air at a temperature of 20 degrees Celsius. The pressure of air inside the ball is 1.90 times 10 to the power 5 pascals. Now during a tennis match, the temperature of the air inside the ball rises to 35 degrees Celsius, and the volume of the air still remains constant. The pressure of the air inside the ball is now, and we're given our 5 possible responses. So our relationship sheet, we're just dealing with pressure and temperature. So we look that up, we get the following relationship. P1 over T1 is going to equal to P2 over T2. That's our relationship here. But the most important thing to recognise is that the temperature for this relationship to work must be in Kelvin. So if we've got temperature T1, which we now know is 20 degrees Celsius, we have to change that into Kelvin. And to do that, we know we've got to add on 273, and we're going to get an answer of 293 Kelvin. So we've got the first temperature. The second temperature is found the same way. It's going to be 35 degrees, so 35 degrees Celsius. We have to add on 273, and we're going to get a temperature of 308 K. So that's us now got our two temperatures. All we have to do is plug it into the relationship. So P1 is going to be 1.90 times 10 to the power 5 divided by, and we're looking for T1, which is 293, so it's 293, and that's got to be equal to the second pressure divided by the second temperature in Kelvin, which is 308. Now a simple multiplying across the way, cross multiply to get our answer. So we have got the following. We've got 1.90 times 10 to the power 5 divided by 293, and we multiply both sides by 308, then 308 on the right hand side will cancel, and we're left with pressure 2. Do that in your calculator and we get pressure 2 comes out to be the following. It comes out to be 1.997, so 1.997 times 10 to the power 5 pascals. But we've been dealing with 3 significant figures, so we have to reduce this to 3 significant figures, and the third significant figure is a 9, which means this rounds up to a 0, that goes up to a 0, and we're left with the following, left with 2.00 to 3 significant figures times 10 to the power 5 pascals. That's the new pressure inside the tennis ball. The correct response for that, 2.00 times 10 to the power 5, is response D.